So large bodies of water, oceans, have a moderating effect. They kind of tend to diminish the temperature swings of coastal locations. But large bodies of water tend to be kind of have currents in them that are warm currents or cold currents. And I don't know if you remember, but at the end of chapter 2, we kind of talked about this idea that there are big circulations made up of several currents that ultimately the oceans transport energy, a surplus of energy that's at the equator towards the poles. And in doing so, some of these ocean currents are warm and some of these ocean currents tend to be cool. Now, what creates these ocean currents, we'll talk more about that later, but actually it's kind of the prevailing wind that creates these ocean currents. It's kind of neat. So, for instance, if you look at the North Atlantic, we have an ocean basin. We have a series of currents that tend to go clockwise around the northern Atlantic Ocean. And so we tend to have kind of a warm Gulf Stream, you'll see that here in a minute, and a cooler Bengalia current. I'll show you how that works here in a minute. So then, just because you're a location on the coast means that you'll have kind of a lower temperature range throughout the year, but depending upon the temperature of the current that you're influenced by, you'll tend to have warmer or cooler temperatures. I'll show you how that works. And just kind of to interject something, as we've been talking about large bodies of water, remember that the Earth is about 70-75% covered. The Earth's surface is covered with large bodies of water. But the northern hemisphere has a fair bit less large bodies of water than the southern hemisphere. So kind of keep that in mind as we go throughout talking about the difference between the northern and the southern hemisphere. But what you're looking at here is to try to highlight the warmer temperatures associated with that the Gulf Stream. Okay, so this is part of the North Atlantic Ocean basin, and this is a Gulf Stream current carrying warm water from the equator towards the North Pole. Now, one of the things about here in the United States is that the ocean current over here on our east coast is warm, and the ocean current over there on our west coast actually is cold, and I'll show you, I think the next map kind of highlights that. So this is a map that I've shown before, and the Gulf Stream we saw just a minute ago, that warm water right here, part of what we call a larger ocean gyre around the North Atlantic, going, what I said, clockwise around a central high pressure in the middle. But then over here in our west coast, notice that we have in the North Pacific, again counterclockwise, and so actually we have the California current, which is going from the pole towards the equator, so it's a cold current. So kind of along those lines, we're going to look at a climatogram here of two locations in South America. And in South America, there's a Brazilian current that is bringing warm water from the equator towards the South Pole. And on the west coast, there is a Peru current, and it is bringing cold water from the poles towards the equator. So if we compare Rio de Janeiro, it's this one up here. Notice that first off, it doesn't have much of a temperature swing, does it? You know, here's its range because it's a coastal location, I would say primarily. But the other thing, if we compare its temperature throughout the year with the temperature of Arica, notice Arica has a similar temperature range, but notice that Arica's temperatures are all, depressed. It's all just a little bit cooler there on the west coast of South America because of that cold current.